with the summation notation, the same idea, is the sum of the two integrals from a to b from f of x dx, and of course from a to b from g of x dx. I'm going to use this and put both properties together. What both properties? So if I have f of x minus g of x and the integral from a to b from f of x minus g of x dx, I have the same thing but with minus. And here's another property. We already used it. The integral from a to b from a constant times f of x dx. The constant goes in front. The integral from a to b from f of x dx. Okay. The other thing before we look at problems, and please choose, I'll tell you which page, is the average of a function. So f average on the interval a comma b is 1 over b minus a multiplied by the integral from a to b from f of x dx. This is the way we calculate the average of any function. But we have to have the function. If we don't have the function, we cannot determine its average. Okay. On page 412, let's start by looking at first the problems 1 through 10, and then we'll look at other applications and also determine the average function value. 34 through 44. Okay, ready? Would you like to pick, or I will? Okay, I'm going to start with 5 on 412. We have f of x equals negative x squared minus 6x plus 7 for x less than 1, and 3/2 x minus 1 for x greater than or equal to 1. I'm looking twice to make sure I copied it correctly. Okay, so we're asked to find the area under the graph between -6 and 4. We notice that the function is continuous everywhere, and it has to be continuous at 1 for sure. So at 1, I have -1 minus 6 plus 7 is 0. And it doesn't have to be actually continuous because we have to break the interval up into -6 to 1 and 1 to infinity. So for each integral, the piece has to be continuous. But the function doesn't have to be continuous everywhere. So the area will be the integral from, since you see it's breaking up at 1, between -6 and 1, plus the area, the integral between 1 and 4. -6 to 1, because this is x less than 1, it's going to be between, applied to -6x minus, x squared minus 6x plus 7. Don't forget the dx. And the integral from 1 to 4 is from 3/2 x minus 1 dx. This function has to be continuous on this interval, otherwise we cannot calculate this definite integral. And this function has to be continuous on the interval 1 to 4, otherwise we cannot calculate this integral. Okay, so fundamental theorem of calculus, I have to apply I have to find the antiderivative. Negative x to the third over 3 minus 6x squared over 2 plus 7x from negative 6 to 1, and plus 3 halves x squared over 2 minus x from 1 to 4. So let's stop for a second and see if you have any questions. I don't want to rush. I want to see if you have any questions, please. Anything. Anything for me here? I'll get a sip of water. Anything? Any questions for me?
So you only use the straight line from what it says from 6 to 1. You only use that for integrals?
This bar?
Yeah.
This bar, you don't have to use it, but you have somehow you have to write that you have to evaluate this at 1 and then subtract when you evaluate at negative 6. This only says that I'm evaluating now. So remember we had dy over dx, and when we evaluated for x equals 1, and we just determine whatever. This is all it says. It says plug in 1 and then subtract when you plug in 6. That's the fundamental theorem of calculus. So I find the antiderivative, and then a vertical bar says that I'm going to plug in b, and then I'm going to subtract when I plug in a. Is that okay?
Yeah.
That's all it signifies. Nothing really. It just says I'm going to plug in the top, and I'm going to subtract when I plug in the denominator. The lower limit, I meant to say. Okay, so moving on then here, let's finish it up. So when I plug in 1, negative 1/3, minus 3 plus 7, minus, when I plug in negative 6, I will have 6 to the third. It will be negative, but with minus in front, divided by 3. And this will be minus 3 times 36, and then plus 42. Plus, I'll come back. Now, I have 3 over 4 times 16 and minus 4. But minus 3 over 4 times 1 minus 1. So I plugged in 1, and I got this. I subtract when I plugged in negative 6. It's good that I'm looking. Negative 42, so I'm plugging in negative 6. That changes into positive. This does not change because negative 6 squared is 36, but this is negative 42. Now when I plug in 4, I have 3/4 and then 16 and minus 4. Minus, when I plug in 1, 3/4, 1, minus 1. Okay then, so negative 1/3 and plus 4. Okay, then how much is this? 6 to the third, and divide that by 3, 72. Okay, so minus 72, and then plus 108, yes, and then plus 42. I'll simplify, and I get 12 minus 4, which is 8. And 3/4 minus 1 is negative 1/4, but with minus in front, plus 1/4. Okay, I'm just gonna punch in my numbers. 108 plus, what is that, 50 plus 4 and minus 72. Let's see what we get. 90. So this is negative 1/3 plus 1/4 and plus 90. And this is 12, a 4, a 3, and a 12. So negative 4 plus 3 will be negative 1, and this will be 1080, so it's 1079 over 12. Any questions? Any questions? And this was the property. one of the properties that we just mentioned. The integral from a to b is the integral, or a to c is the integral from a to b plus the integral from b to c. Any questions here? Okay, here's a very interesting application of integration, among other things, in real life situations. Finding areas between functions, or among functions, or among expressions. We'll see in a moment. Okay, so let's start with a simple example like 17. Why simple? Because I see a linear function and I see a quadratic function. And this cannot be difficult. So we are asked to find the area of the region bounded by the graphs. So please remember that credit will not be given if you do not graph and if you do not show the area. So please make a note of that. Okay, so there is no problem here. I need two ordered pairs when x is 0, y is 2. When y is 0, x is -2. This I know how to plot, right? It's when x is 0, y is 0. When y is 1, y is 1. When x is -1, y is 1, etc., etc. I know how to graph. That's a basic function. Okay, so let's graph. 0, 2, and -2, 0 is our first function, is the line. So this is y equals x plus 2. Now I will graph y equals x. So here's y equals x squared. 0, 0, 1, 1, 1, 1, -1, 1 I meant to say. So here's the graph. So this is y equals x squared. As we notice, there is an area enclosed. This is the area that we are asked to find. How do I determine that area? Here's what we're going to do. We're going to find the points of intersection. And we are going to subtract from the area under the graph of the linear function. We will subtract the area under the graph of the quadratic function to get the pink area. One more time. We will determine the area under the line. We will determine the area under the quadratic function and subtract them to get the pink. But first we have to find the points of intersection. So number 1, find points of intersection. That's our first step. Okay. So I'm given that y equals x plus 2 and y equals x squared. Obviously, I have to set them equal to each other. This y must equal this y at those points of intersection. So they are the same. X plus 2, I move everything to one side because it's quadratic. I use a quadratic formula or factor, x minus 2 and x plus 1. I get x equals 2 and I get x equals -1. What does this mean? It means that this point is here at -1. It means that this point is here at 2. So in order to find the pink area, the integral between -1 and 2, from the upper function minus the lower function. The upper function solved for y is x plus 2. the lower function solve for y because it may not be solved for y. I may have to solve for y. It's that. So now I continue. From here on, I apply the fundamental theorem of calculus. This is a continuous function on the interval -1, 2. And I have x squared over 2 plus 2x minus x cubed over 3, and from -1 to 2. I will plug in 2. 4 divided by 2 is 2. 2 times 2 will be 4, minus 8 over 3. But minus, don't forget parentheses, so you don't forget to distribute a negative sign. Minus, when I plug in -1, that will be 1/2. This becomes -2. But this becomes -1 with minus in front, so it's positive 1/3. 2 plus 4, 6, minus 8/3. Minus 1/2, plus 2, minus 1/3. This kind of area, let's come back for a moment. This must be positive. This area must be positive. It's an area enclosed between two graphs. Okay, so I have 6 plus 2, which is 8. -8/3 minus 1/3 is -9/3, which is -3. And I do have minus 1/2. So this is 5 minus 1/2, 10 minus 1, 9/2. So the area enclosed between those graphs is 9/2. Feel free to choose any other area that you would like to determine, enclosed between two functions.